Hey guys, this is Wendell Helton with Helton Construction, and we're doing an in-floor heat addition here, and I want to show you some specific things that we do. One is, instead of using two 2x6s, we use a 2x8 right there. Also, you can use it as a screed board, and plus it's there for tack strip for the carpet installers. Next is, when we have a window, we put these 6 inches on center, and as we get away from the window, then we put them 10 to 12 inches on center. So this is the entryway, and so we have a door, right? So in front of this door, when you open the door, all that cold air is going to come in, so we put these 6 inches on center. And we put it out usually to the swing of the door, maybe just a little past. And then, as you can see, we go to 12 inches on center. Also, we have to fill up all little cracks and everything, because gypcrete runs thin, like water. So, with the gypcrete floor, is what we're doing is we're heating a thermal mass. And the gypcrete is the thermal mass that radiates heat, hence the name in-floor heat. So these guys that run it just underneath the subfloor rely on the subfloor plus the floor joist as a thermal mass to radiate heat back up. Well, wood is not a very good thermal mass. Wood is porous, so it doesn't hold the temperature as concrete does. So here we are in the bathroom, and everybody likes nice warm feet in the bathroom. So again, we run these 6 inches on center, and it has its own thermostat. So it is zoned. You can set your thermostat in here, however temperature you like, and you always have warm feet. And so here's the shower. In the shower, we're going to do a mud pan, but we're going to pour the gypcrete over and then set the mud pan on top. So you're really going to have a large thermal mass there, and your shower pan will never be cold to your feet, ever. And then we have the toilet. Don't need a lot of warmth in that little spot. But as we go through here, oh, one other thing. So right here is where we have all the vanity cabinets, and we do not need tube run underneath the vanity cabinets. We don't need to heat up lipstick and armpit stick and all that other stuff to kind of make it soft and melty. So we do not run tubing underneath the cabinets. So over here, in this window, we're going to put a built-in bench. We just want to semi-warm that in. We don't need to heat it up a lot because she's going to store blankets and stuff in there. But as we come out away from the window, we put them tighter, closer together, and that makes where the cold air rolls off the window and hits the bench, it will heat that up. Same way over here. And then when we run them next to the wall, we run them about 6 to 8 inches on center on an exterior wall. So if we have a window, say like right here, we run them 6 to 8 inches on center to heat that cold spot in the window, and then we'll go 10, 12 inches on center from there. I get a lot of complaints about people say one side of my house is warm and then the other side of my house is colder. That's because they don't run enough loops. And here's the supply loop and the return loops that go into the boiler. We spray foam that off. We'll trim that off so the gypcrete doesn't spill off into the garage, because this is the common wall between the house and the garage. But you need to run the right amount of loops and not too far, because your delta T is the difference of when it leaves the boiler and when it returns to the boiler. We don't want that too big of a spread. We want that closer together. And so some contractors put in a higher flowing pump, which is not necessarily good, because if you're rushing it through, it doesn't have a chance to heat up the thermal mass. So make sure that they only run a certain amount of feet. It's usually 160 to 200 lineal feet of tube per run. So this room here is 1,000 square feet. And we have 4 supplies, 4 returns. As it's closer to the exterior wall, we keep them closer together, because we want to heat that cold spot first. Same way with over here. Even though there's not a lot of windows, we still have an exterior wall. We want to run those closer together to heat and get that thermal mass heated up, so the cold air doesn't disturb it. And as you notice, our vapor barrier, we're getting ready to pour the gypcrete. Our vapor barrier is trimmed with Tremco sealant, and this works as a gasket for our vapor barrier. That way, we have no chance of water vapor getting behind the vapor barrier. We do it at the bottom, up the sides, down the top, around the lid. We want our vapor barrier sealed completely. So I hope you guys got a little information on this short video. I do house a lot of calls saying, hey, I got a 1,200 square foot house and my living room is warm, but my bedrooms are cold. One is that they don't put enough zones in with thermostats. 2 is the runs of pipe, or PEX, is too long. So it comes out here hot, comes out of this hot. By the time it works over here to the other part of the room, it's cooled off. So it comes out here 180. By the time it gets clear over there to the corner, it's like 90 degrees, half the temperature. So heck no, it's not going to stay hot all the way over there when it's dispersing heat in the thermal mass. Thermostats, we try to put one for main living area,